and that is to find the sum of the sequences. So what I mean, does everybody recognize that this is a geometric sequence? Is everybody okay on that? Can everybody read that stuff? Do you understand what I'm saying there? Right? A1 is the first term, the next term is going to be multiplied by R, the one after that's going to be multiplied by R, and so on. Okay. So if I wanted to add all of them up, if I wanted to add all these terms up, and so on, up to the nth one, okay, then here's your formula for that. Here's your formula for that. Okay. All right, is everybody okay on that? Everybody get that down? Okay, you guys got that? Not yet? Okay, let me pause this. So the sequence that we just did, okay, awesome, let's get on track here. Zach, let's get on track. So the sequence that I just gave you, awesome, Myra, it's called a finite sequence. It's got a finite number of terms. And then you get a sequence, a geometric sequence that might be an infinite sequence. In other words, it goes on and on and on. Like, for example, here, it's telling you that it's going on and on and on. It doesn't end at the nth term. Okay? So remember from the previous slide, our sum of a geometric sequence was something like this. Right? From the previous slide. Right? So in an infinite sequence, if this condition is met, everybody understand what that condition is saying? What's it saying?
That
R is less than 1? Yeah, so it could be, for example, minus a half. R could be minus a half. And its absolute value is less than 1.
So it can't be like 2.
Cannot be 2, cannot be 1.1. Cannot be 1.0001. Cannot be 1 either. It's got to be strictly less than 1. Yes. So in other words, if you're looking at the number line, it means that R has got to be between these values only. Okay, that's all it means. Now what I'm saying is that if that condition is met, then this formula becomes that. Is it kind of obvious to you or not really? Because remember what's happening to n in an infinite sequence. Where is n going to go? What does it become? Infinite. Okay? So what you're going to get there is, for example, you're going to get 1/2 to a huge number. Right? Now get your calculators out and experiment. Okay? What's 1/2 to the 20th power? What's 1/2 to the 200th power? And compare those numbers. See what's happening to it. Okay. So I'll do the first one, you do the second one, okay? So this is not an infinite sequence, okay? And the formula I'm going to use is this one here. What's A1 equal to? 64. What's R equal to? Negative 1/2. And then you just go plug chug that. Okay, so S sub 7, because I've got 7 terms, okay, is equal to 64 times 1 minus negative a half. Make sure you use your protection properly here. Over 7 over 1 minus a negative half. And just go chug that on your calculator, okay? Go chug that on your calculator. So for those people who've got their graphing calculators out, do it 2 ways, okay? Chug this way, and then chug this way. Okay? Make sure you get the same answer in both cases. So don't just rely on your graphing calculator to do that, okay? Because on Monday, the quiz is not graphing calculator, okay? It's scientific calculator. Sorry? Okay, remember what the sequence means, okay? This sequence means you put n equals 1. You get 1.2. You put n equals 2. 0.3 squared is 0.9. Times 4 is 0.36. Okay? So you should get the same answer, okay? So again, be careful, okay? This is a question that's designed for little kiddies like you to trap you. Okay? So what I'm saying is that essentially what you want to do is you want to write this in long form, okay? So in other words, write this as if you got individual numbers. So you got 1.2 plus 0.36 and so on. So now A1 is 1.2. R is still 0.3. And then you're going to chug in this formula here. Okay? You're going to chug on that formula. And you should get 1.71428. 3. Okay? Rounded to 4 places. Is everybody okay? Did everybody figure out the trap in here? Yes? Okay. Okay, last problem, and then we are done. This is an infinite sequence, yes? N was 12. Yeah, because here's n equals 1, and when you go down, this is, notice what this is, okay? This is 4 times 0.3 to the 1. So n is 1, n is 2, all the way to n is 12. Yes?
I didn't use a long way, and I just used plug it in, and I still get 1.
You should get 1.7. Oh, no, I'm not asking you to do the long thingy here, dude. I'm not asking you to write 12 terms here. I'm not asking you to do that. That's pretty dumb. Yeah, I'm not asking you to do that. All I'm asking you to do is recognize that the first term is 1.2, not 4. That's all I'm telling you. That's the only trap. Okay? All right? Last problem here. So again, this one's got kind of trapped, so make sure you don't fall into it, okay? This is an infinite people to see as well. So in order to avoid the trap in these kind of problems, okay, people, the way to avoid a trap in these kind of problems is to write the first terms of the sequence by hand. So if you put n equals 0, what do you get? 1. When you put n equals 1, what do you get? 1/10. When you put n equals 2, 100th? Yes? Everybody see that? Now you can see the sequence. What's A1 equal to? 1. What's R equal to? 1/10. And then you guys go smoke this formula, right? Okay? Yep. Sorry? Would you be okay if I wrote this? Because A1 is 1. 1 minus 1 over 10 gives you this. Okay? So if I asked you for an exact answer, this is what I would expect to see. Can I erase the board? Sure. Sorry, my bad. Can everybody read this quickly stuff here? Can anybody rewrite that? You guys got this? This is just plugging in A1 is 1, R is 1 over 10. So this is 1 over 1 minus 1 over 10, which is 10 over 9. You guys okay on this? Yeah? Sure, kind of, sort of, maybe? Okay, I'm done.